Good day and welcome everyone to this mandatory training for the upcoming SOLAS updates in regard to the design, inspection, testing of onboard lifting appliances and anchor handling winches. The aim of this training is to further enhance your knowledge and expertise gained from your experience inspecting and testing of class lifting appliances, cargo gear, and ensuring we meet the requirements of a competent person. If you have any questions or queries, please write them in the chat and we will answer you during this or after the training. We have split the presentation into 7 sections. We'll start with section 1, the amendments, background and the key differences to the ILO. In section 2, we will cover the actual amendments that will enter into force on the 1st of January 2026 for SOLAS Part A and A1. Section 3 will cover in detail the guidelines set out in the circulars 1662 and 1663 in regard to anchor handling winches and lifting appliances. Section 4 covers some of the common types of lifting appliances used on board the vessels. Section 5 covers some of the common deficiencies noted on lifting appliances. That's both from P&I and also from our own records. In section 6 we have a brief overview of the applicable rules and procedures that BV Marine and Offshore have. And finally in section 7 we'll take a main look at the aspects of the ships in service surveys on board a vessel. So the background. From the 2nd to the 6th of March 2020, the IMO Subcommittee on the Ship Systems and Equipment SSE convened for their 7th session in the IMO headquarters, London, in the United Kingdom. Progress was made on key safety issues, including preventing accidents with lifting appliances and winches. The subcommittee agreed to draft guidelines for lifting appliances and made progress on the corresponding draft guidelines for anchor handling winches. Both sets of guidelines were designed to complement the relevant draft SOLAS regulation, also under development. A correspondence group was established to continue the work. The guidelines form part of the subcommittee's work to prevent accidents relating to lifting appliances and anchor handling winches which have caused harm to operators and damage to ships, cargo, shore-based structures and subsea structures, as well as to the marine environment. The IMO Maritime Safety Committee, MSC, the 107th session was held in London on the 31st of May to the 9th of June 2023, where one of the key outcomes was the adoption of the amendments to SOLAS Chapter 2.1 for a new regulation 313 concerning onboard lifting appliances and anchor handling winches, OLAW, with an entry into force date of the 1st of January 2026. Let's have a look at what this new regulation means for interventions where previously there had only been inspections with the scope of ILO Conventions 32 and 152. A fundamental difference lies in the scope of their application. ILO Conventions 32 and 152, these conventions primarily focus on the occupational safety and health of dock workers. Consequently, their scope is largely limited to lifting appliances used for cargo handling operations in port. SOLAS Regulation 313, this new regulation casts a much wider net. It applies to a broader range of permanently installed lifting appliances on board ships, not just those used for cargo operations. The transition from ILO conventions to the new SOLAS Regulation 313 represents a significant shift in the maritime industry's approach to the safety of lifting appliances. The key takeaways are the expanded scope to include a wider range of onboard lifting equipment, higher standards for design, construction and installation of new equipment, the retrospective application to existing lifting appliances, and the more rigorous requirements for maintenance, inspection and documentation. This new regulation aims to create a more uniform and robust safety culture around all lifting operations at sea, moving beyond the port-focused approach of the past. So Resolution MSC 532-107 was adopted on the 8th of June 2023 and it will enter into force on the 1st of January 2026. The resolution brings about amendments to the International Convention for the Safety of Life at Sea, SOLAS, and the following regulations within Chapter 2.1, Construction, Structure, Subdivision, Stability, Machinery and Electrical Systems, have been amended with these new paragraphs. So Chapter 2.1 Part A Regulation 2, the definitions have been changed and updated. Item 30. Lifting appliance means any load handling ship's equipment. So point 1, used for cargo loading, transfer or discharge. Point 2, used for raising and lowering hold hatch covers or movable bulkheads. Point 3, used as an engine room crane. Point 4, used as stores cranes. Point 5, used as hose handling cranes. Point 6, used for launch and recovery of tender boats and similar applications. And point 7, used as personal handling cranes. Item 31. The definition of an anchor handling winch is any winch for the purpose of deploying, recovering and repositioning of anchors and mooring lines in subsea operations. Vessels classed with Bureau Veritas that fall into this application have a classification notation anchor handling as stated in Rule Note 467 Part A Chapter 1 Section 2 and Part E Chapter 2. Item 32. Loose gear means an article of ship's equipment by means of which a load can be attached to a lifting appliance or an anchor handling winch, but which does not form an integral part of the appliance or load. Item 33. The expression installed on or after the 1st of January 2026 is provided in Regulation 313. This means, point 1, for ships the keel of which is laid or which is at a similar stage of construction on or after the 1st of January 2026, any installation date on the ship, or, point 2, for ships other than those specified in point 1, including those constructed before January the 1st, 2009, a contractual delivery date for lifting appliances or the anchor handling winches, or in the absence of a contractual delivery date, the actual delivery date of the lifting appliance or anchor handling winches to the ship on or after the 1st of January 2026. So, the new regulation. Chapter 2.1, Part A1, Regulation 313, Lifting Appliances and Anchor Handling Winches, and this is the new regulation that's been added to the chapter. What vessels and type of lifting appliances is this applicable to? Unless expressly provided otherwise, this regulation shall apply to lifting appliances and anchor handling winches and loose gear utilised with the lifting appliances and anchor handling winches. Notwithstanding the above, this regulation does not apply to lifting appliances on ships certified as MODUs, marine offshore drilling units, lifting appliances used on offshore construction ships such as pipe, cable laying, repair, offshore installation vessels, including ships for decommissioning work, which comply with standards acceptable to the administration, integrated mechanical equipment for opening and closing hold hatch covers, life-saving launching appliances complying with the International Life-Saving Appliance Code, the LSA code. The administration shall determine to what extent the provisions of paragraphs coming into the following slide, 2.1 and 2.4, do not apply to lifting appliances which have a safe working load below 1,000 kilos. Design, construction and installation. Lifting appliances installed on or after the 1st of January 2026 shall be: point 1. Designed, constructed and installed in accordance with the requirements of a classification society, which is recognised by the administration in accordance with the provisions of Regulation 11.1.1 or standards acceptable to the administration which provide an equivalent level of safety. And, point 2, load tested and thoroughly examined after installation and before being taken into use for the first time and after repairs, modifications or alterations of a major character. The following updates will specifically affect new construction and any vessels undergoing lifting gear modifications after the 1st of January 2026. Anchor handling winches installed on or after the 1st of January 2026 shall be designed, constructed, installed and tested to the satisfaction of the administration based on the guidelines developed by the organisation. Lifting appliances installed on or after the 1st of January 2026 shall be permanently marked and provided with documentary evidence for the safe working load, SWL. For ships in service surveys, the following amendments need to be highlighted for any renewal surveys being completed after the 1st of January 2026. Lifting appliances installed before the 1st of January 2026 shall be tested and thoroughly examined based on the guidelines developed by the organisation and comply with paragraph 2.3, which means they shall be permanently marked and provided with documentary evidence for the safe working load, no later than the date of the first renewal survey on or after the 1st of January 2026. Anchor handling winches installed before the 1st of January 2026 shall be tested and thoroughly examined based on the guidelines developed by the organisation no later than the date of the first renewal survey on or after the 1st of January 2026. Maintenance, operation, inspection and testing. All lifting appliances and anchor handling winches, regardless of installation date, and all loose gear utilised with any lifting appliance or anchor handling winch shall be operationally tested, thoroughly examined, inspected, operated and maintained based on the guidelines developed by the organisation. These are MSC.1/circulars 1662 and 1663, which we will cover next in this presentation. Inoperative lifting appliances and anchor handling winches. Except as provided in SOLAS Chapter 1 Part B Regulation 11, which covers the maintenance of conditions after survey, Part C, while all reasonable steps shall be taken to maintain lifting appliances, anchor handling winches and loose gear, to which this regulation applies in working order, malfunctions of the equipment shall not be assumed as making the ship unseaworthy or as reason for delaying the ship in ports, provided that action has been taken by the master to take the inoperative lifting appliance or anchor handling winch into account in planning and executing a safe voyage. As previously stated, the Maritime Safety Committee at its 107th session, and further to the adoption of Resolution MSC.532/107, also approved the guidelines MSC.1/Circ 1662 and 1663 for lifting appliances and the guidelines for anchor handling winches to support the application of SOLAS Regulation 313. These guidelines are made mandatory by the amendments to SOLAS, where it is stated that the specified equipment shall be designed, constructed, installed, tested, thoroughly examined, inspected, operated and maintained based on these guidelines developed by the organisation. The following definitions are stated in Circular 1662, and this is the guidelines for anchor handling winches. Definitions 1 through 6 are specifically for anchor handling winches, whereas definitions 7 to 14 are also used in the guidelines for lifting appliances. Brake holding force is the maximum force for which the winch brake is designed. Brake holding capacity is the maximum line pull that the winch brake can withstand without slipping of the brake. Maximum line pull is the maximum sustained force the winch is capable of pulling. Static bollard pull is the maximum sustained pulling force a vessel is capable of generating at maximum power i.e. 100% of the maximum continuous rating, and 0 forward speed. A wire means a dedicated line, so a wire rope, synthetic rope or chain cable, used for the handling of anchors by means of an anchor handling winch. The wire may also include loose gear. Chain stopper is a device used for securing and holding a section of wire, thereby relieving the load on the winch drum. Competent person, the surveyor, means a person possessing the knowledge and experience required for the performance of duties specified in these guidelines and acceptable as such to the administration. Inspection means an assessment carried out by a responsible person to ascertain if the anchor handling winches or associated loose gear are in good working condition for continued safe use. A responsible person means a person appointed by the master or company, as defined in SOLAS Chapter 9, Regulation 1, Definitions, Item 2, as appropriate, possessing the knowledge and experience required for the performance of duties specified in these guidelines. Thorough examination means a detailed assessment carried out by a competent person to determine whether or not the anchor handling winches or associated loose gear are in compliance with the applicable requirements of the administration. Certified means that the anchor handling winches or associated loose gear have been verified and documented as compliant to the satisfaction of the administration or a recognised organisation acting on its behalf. Maintenance means any activity carried out by a responsible person to keep the anchor handling winches or associated loose gear in good working condition for continued safe use. Operational testing means a test carried out by a responsible person to verify the correct functioning of a component or operation of the anchor handling winches and/or associated loose gear. Load test means a test in excess of the maximum line pull carried out in the presence of a competent person in order to test the structural integrity of the anchor handling winches and their attachment to and the adequacy of their supporting structure. The following definitions are stated in the Circular 1663 for the guidelines for lifting appliances, but we'll only discuss the two main definitions, definitions 9 and 10, that differ in context to those listed in the previous slides and defined specifically for lifting appliances. The two definitions that are specific to lifting appliances and differ to those referenced in Circular 1662 are as follows. Safe working load, SWL, is the maximum static load at a specified radius which a lifting appliance or item of loose gear is certified to lift for specified operating conditions. A certificate of test and thorough examination means a certificate issued by a competent person upon satisfactory completion of the test and thorough examination of the lifting appliance and/or loose gear. The following slides give the key bullet points of the guidelines, but as we go through, we'll talk about them in more detail. Lifting appliances installed on or after the 1st of January 2026 should be designed, constructed and installed in accordance with the requirements of a classification society, which is recognised by the administration, or to standards that are acceptable to the administration and provide an equivalency regarding safety. Existing lifting appliances that hold valid certificates of test and thorough examination under another international instrument that is acceptable to the administration and issued prior to the entry into force of the SOLAS regulation amendment should be considered as compliant with SOLAS regulation 21313.2.4. Lifting appliances to which SOLAS Regulation 21313.2.1 applies should be load tested to the satisfaction of the administration after installation and before being taken into use for the first time and after any repairs, modifications or alterations of a major character. Before being put into use for the first time, lifting appliances should be certified as compliant with the scope of demonstration of compliance comprising of the following: a plan appraisal of the lifting appliance and foundation connections, verification of materials, survey, testing and examination during fabrication, verification of component certificates including its loose gear, and testing and thorough examination when installed on board. Lifting appliances to which SOLAS Regulation 13.2.4 applies should be load tested to the satisfaction of the administration no later than the date of the first renewal survey on or after the 1st of January 2026, or after repairs, modifications or any alterations of a major character. Repairs and modifications or alterations of a major character are those which change the safe working load of the lifting appliance, or affect the strength, stability or service life of the lifting appliance, or affect the primary load bearing structure of the lifting appliance, or modify the functionality of the lifting appliance or any part thereof which may affect its strength, safety or structural integrity. Lifting appliances to which SOLAS Regulation 213.13.2.1 and 313.2.4 apply should be retested at least once in every 5 years. For load testing of lifting appliances intended for use whilst the ship is in port or sheltered waters, the test load, as set out in Table 1 of this guideline, should be established using the safe working load. For lifting appliances intended for open sea operations, the test load should be to the satisfaction of the administration or a classification society which is recognised by it, taking into account the applicable dynamic loads. Where the safe working load of the lifting appliance is undocumented and design information is not available, for example the lifting appliance was installed on board before the 1st of January 26, and the manufacturer no longer exists, the test load should be calculated using Table 1 based on a safe working load nominated by the company to the satisfaction of the administration. Lifting appliances should be subject to a thorough examination upon completion of any load tests and annually. Where thorough examination does not form part of the renewal or annual survey, verification that thorough examination of the appliances have been completed to the satisfaction of the administration should take place during the renewal survey under SOLAS Regulation 1.7 or under the annual survey under SOLAS Regulation 1.10 as applicable. Load testing and thorough examination may be documented in any convenient form, provided each entry contains the necessary information, is clearly legible, and is authenticated by a competent person. The information to be included in the Certificate of Test and Thorough Examination should include the ship's name, IMO number, call sign, port of registry, and owner's name. It should also include the lifting appliance description and identification, angle which the load test was applied, the test load in tons, and the safe working angle or radius. The endorsement should include the date the certificate is valid until, and the completion date and place of the test and thorough examination took place, the date of issue, and the signature and stamp of the issuing authority. Alternatively, other formats may be used which are acceptable to the administration, such as those of a classification society recognised by the administration. If on completion of a thorough examination the competent person considers the lifting appliance to be unsafe for the operation or not in compliance with the applicable requirements, then that lifting appliance should be taken out of service until any deficiency is rectified to their satisfaction. The lifting appliance should be clearly marked not to be used, and the status should be recorded in the Register of Lifting Appliances. A record of thorough examination and load testing should be maintained in a register of ships' lifting appliances and cargo handling gear and should be available on board. The safe working load and other information essential for the safe operation of the lifting appliance, example the maximum or minimum slewing radius or boom angle, should be permanently and clearly marked in a conspicuous place on the lifting appliance. In all cases where the lifting appliance has had a variable load radius rating, the safe working loads corresponding to the minimum and maximum radius should be clearly marked in a conspicuous place on the lifting appliance, and, in addition, a diagram of the permissible maximum loads over the entire range of use should be displayed in a position that's clearly visible to the operator. The maintenance, inspection, operational testing and their respective intervals should be in accordance with the manufacturer's recommendations, industry standards and guidelines, or classification society requirements and recommendations that are acceptable to the administration. All lifting appliances should be considered vulnerable to the marine environmental conditions, which in turn may lead to significant and accelerated deterioration and corrosion, and the inspection and maintenance regime should be implemented accordingly. The inspection and maintenance of lifting appliances may involve working at height, in closed space entry, and other hazards. These hazards should be considered when developing the relevant procedures for undertaking such tasks, including safe access. Examples of items requiring particular attention may include any corrosion, damage of primary structural members, including crane jibs, crane housings, slewing column, pedestals, foundations, foundation connections, including welds and bolts. Any wear, corrosion, damage of mechanical components, including winches, hydraulic cylinders, slew bearings, sheaves, pins. Ensuring the correct setting and functioning of safety, protection and limitation devices. The condition and correct functioning of the lifting appliance as a whole, in particular hydraulic or pneumatic arrangements, hydraulic pneumatic cylinders, motors, hoses, piping, winches, brakes and drums. The corrosion and damage to all means of safe access to the lifting appliance, including attached maintenance platforms and extensions with particular attention to support brackets and welds, and the certification and identification of the ropes. Should there be any damage, broken, worn or corroded ropes, including their termination, these should be inspected and discarded according to the manufacturer's recommendations, relevant industry standards, international standards, for example the ISO 4309-2017, or requirements of the classification societies acceptable to the administration. If on completion of an inspection the responsible person considers the lifting appliance to be unsafe for operation or not in compliance with the applicable requirements, then that lifting appliance should be taken out of service until any deficiency is rectified to the satisfaction of a competent person. As previously covered, regarding unsatisfactory thorough examination, the lifting appliance should clearly be marked not to be used and the status should be recorded in the Register of Lifting Appliances. Personnel operating lifting appliances should be qualified, familiarised with the equipment and also authorised by the master. All personnel involved in a lifting operation should understand their role during the operation and the signals that may be required to commence, coordinate or stop the operation. Procedures and instructions should relate to the specific type of lifting appliance and should be provided in the operations manual. Safe means of access to the lifting appliance and loads requiring attachment detachment should be established. Personnel operating lifting appliance should consult the operations manual for any specific instructions relating to the lifting operations. The maintenance manual should, as a minimum, include the following: a description of the required inspection regime and the maintenance schedule specific to the lifting appliance, checklists, list of key tools and or other items that you need to carry out the inspections and maintenance, any specific instructions for routine repairs, technical maintenance information, information on recommended lubricants, oils, filter change requirements, information on any slewing bearing maintenance, lists of replaceable parts and components, as well as the inspection, maintenance, replacement procedures for these parts or components, lists of sources of spare parts, model forms for records of inspections and maintenance, operational test procedures as well as the pre, post operational test inspection procedures. List of components requiring particular attention during inspections, as well as the inspection maintenance procedures for these components. Recommended intervals for the replacement and overhaul of components and equipment. Information on the preservation of the coating and corrosion protection systems. And information regarding special inspection maintenance in cases where the lifting appliance is not operated for long periods of time. Records of the routine inspection and maintenance of lifting appliances or their components or parts should be maintained and kept on board. The records and particulars of inspections and maintenance may be documented and should be authenticated by a responsible person. Any recommendations of the manufacturer for such inspections and maintenance records should be used. An operations manual for lifting appliances should be provided by the manufacturer. Where operations manual for existing lifting appliances are not available from the manufacturer, these may be provided by a competent third party. An operations manual should, as a minimum, include the following for each lifting appliance: the design, operational and environmental limitations, compatible loose gear, safety instructions, and operating procedures, including special procedures if there should be any. For lifting appliances installed before the date of the entry into force of the regulation, the operations manual should be developed with the original manufacturer, design and build data, and take into account any modifications that have been carried out since the original installation. Where the original data or modification data is not available, operations manual should be developed on the current operational procedures and practices. Loose gear utilised with lifting appliances to which SOLAS regulations 213, 13.2.1 and 13.2.4 applies should be designed, manufactured in accordance with the requirements acceptable to the administration or a classification society which is recognised by the administration. Types of loose gear used on board can include, but not limited to, the following: blocks, hooks, shackles, swivels, chains, rings, rigging screws, slings, lifting beams, hand-operated tackles used with pitched chains, rings, hooks, shackles, swivels, permanently attached to other loose gear, fulfilling similar functions to those we've previously listed. All loose gear in use with lifting appliances to which the SOLAS regulation 213.13 applies should have documentary evidence of a proof test and be retested after repairs, modifications or alterations of a major character to the satisfaction of the administration. Where an item of loose gear is tested, minimum test loads should be to the satisfaction of the administration based on Table 2, which will be shown in the following slide. All loose gear should be subject to thorough examination to the satisfaction of the administration. And this should be upon completion of any proof test and annually. Where thorough examination does not form part of a renewal survey or annual survey, verification through examination of loose gear has been completed to the satisfaction of the administration, and if on completion of a thorough examination the competent person considers the items of loose gear to be unsafe for operation or not in compliance with the applicable requirements of the administration, then this is to be dealt with the same way as described in the testing and examination of lifting gear. The maintenance inspection and respective intervals should be in accordance with the manufacturer's recommendations, industry standards and guidelines, or the classification society requirements and recommendations acceptable to the administration, considering factors such as the operational profile of the ship and the loose gear. All loose gear should be considered vulnerable to the marine environmental conditions, which may lead to significant and accelerated deterioration and corrosion, and the inspection and maintenance regime should be implemented accordingly. Loose gear should be inspected by a responsible person before each use. Examples of aspects requiring particular attention may include wear, corrosion, damage, correct functioning of the loose gear, damaged, worn, corroded chains, including their terminations, the certification and identification of loose gear, and physical and chemical degradation, including degradation due to the exposure to the environment. Again, if on completion of an inspection the responsible person considers the loose gear to be unsafe for operation or is not in compliance with the requirements of the administration, then the loose gear should not be used until any deficiency is rectified to the satisfaction of a competent person and dealt with in the same way as mentioned in the previous slides. All certificates of test and thorough examination of certified loose gear should be attached to the register of ships lifting appliances and cargo handling gear. As stated in the previous slide, here we have Table 2 from Rule Note 526, Chapter 5, Section 1. And this has the minimum test loads to be used on the different types of loose gear and their specific safe working loads. All loose gear should be clearly and permanently marked with its unique identification, serial number, the safe working load, and any additional marks required for safe use. In addition, specific types of loose gear should be marked with the following minimum information: ram's horn hooks, the range of sling angle, block and hook blocks, rope diameter, the rigging plan identification marks for blocks if any. Lifting beams, spreaders and frames should have the tower weight, allowable sling angles, details of the safe application of the safe working load in case complex equipment which can be utilized in different ways. Grabs should have the tower weight, and other equipment as per the requirements of the Classification Society, industry standards, or anything that's acceptable to the administration. If there's insufficient space for the marking on the loose gear other than the safe working load, the omitted information should be included in the certificate or be provided by other suitable means. Records of thorough examination, routine inspection, maintenance, and the evidence of proof testing of loose gear should be maintained in a register of lifting appliances and kept on board. The following actions should be taken by the master to mitigate risk posed by inoperative lifting appliances. Take the inoperative lifting appliance into account in planning and executing a safe voyage. Prevent operation of the inoperative lifting appliances. Prevent uncontrolled movement of inoperative lifting appliances or their components using appropriate restraining preventive arrangements. Store inoperative loose gear separately from in-service loose gear and mark it as inoperative. Record a particular lifting appliance or loose gear that's inoperative in the register of ships lifting appliances and cargo handling gear until the necessary repairs have been completed and it's been load tested or proof tested as necessary and thoroughly examined. Also, as stated in SOLAS Part 1, Chapter 1, Part B, Regulation 11C, whenever an accident occurs to a ship or a defect is discovered, either of which affects the safety of the ship or the efficiency or completeness of its life-saving appliances and/or other equipment, the master or owner of the ship shall report at the earliest opportunity to the administration the nominated surveyor or recognised organisation responsible for issuing the relevant certificate. Anchor handling winches and associated equipment should be designed, constructed and installed in accordance with the requirements of a classification society which is recognised by the administration, or to standards acceptable to the administration which provide an equivalent level of safety. In addition to the above, anchor handling winches that fall under the scope of SOLAS Regulation 2.1.3.13.2.2 should also comply with the additional guidance specified under paragraphs 3.1.2 to 3.1.8 of the guidelines, which are as follows. 3.1.2 Speed Control and Handling. The anchor handling winches should be capable of hoisting and lowering in a controlled manner and should be provided with adjustable speed control between the minimum and maximum speeds. The winch operating controls should be designed to pay out the wire by moving the control lever away from the winch operator and heave in by pulling the control lever towards the operator. All operating controls should be permanently marked with signs indicating the purpose and the operating direction. The winch operating control should be of the hold to run type, which will cause the hoisting or lowering motion to automatically stop when the lever is released by the operator. 3.1.3 Tension control. Anchor handling winches should be equipped with tension control to ensure that the system is not overloaded in the event that the anchor being handled gets stuck, entangled, or is exposed to similar situations. 3.1.4 Overload alarm and monitoring. Winches should be provided with continuous load monitors and an audible and visual overload alarm. This should also be programmable for lower levels of load. 3.1.5 Control stations. The main control station should be placed in a position on the bridge which has a clear view of the deck area. Operators should be able to visually monitor anchor handling winches and the associated equipment, and, if the view is obstructed, cameras or video monitoring devices may be used for this purpose. The anchor handling winch may be controlled from one or more positions, provided that the arrangement to prevent more than one position from exercising control at any one time is fitted. Each control station should be provided with means for two-way communication with the main control station, an arrangement to prevent inadvertent actuation, adequate protection of personnel, sufficient illumination. 3.1.6 Spooling device. Anchor handling winches should be equipped with remotely operated spooling devices. 3.1.7 Emergency release. Anchor handling winches should be designed to facilitate emergency release of the load on the wire in a safe and controlled manner, both under normal as well as dead ship conditions. The controls for actuation of the emergency release should be placed at the main control station. Emergency release function may also be available at the local control station. Emergency release controls should be protected against unintentional activation. The design and operation of the emergency release should take into consideration restrictions on the payout speed of the wire due to inertia and any restrictions due to onboard arrangements. The instructions for the operation of the emergency release should be clearly displayed at the navigation bridge and locally at the winch. After an emergency release, the complete anchor handling winch system should be inspected for signs of damage or deterioration. Any identified damage or deterioration should be rectified before the anchor handling winch is put back into service. Note: periodic drills for emergency release and emergency brake operation should form part of the planned maintenance schedule. 3.1.8 Associated anchor handling equipment, the chain stopper. Anchor handling vessels should be equipped with a chain or wire stoppers, hereafter referred to as chain stoppers. A chain stopper should be equipped with an audible alarm which is activated when the stopper is either being engaged or disengaged. A chain stopper should be equipped with an emergency release that is functional in all conditions, including dead ship. Emergency release of chain stopper should include disengaging of pins and other equipment that may prevent the releasing of the wire or cause the wire to get stuck, entangled during the release. Emergency release of the chain stopper should be designed for remote operation and minimize the risk of injury to personnel. The release mechanism of the chain stopper should be protected against unintentional activation. Instructions for the operation of the emergency release should be clearly displayed at the navigation bridge and locally at the emergency release control mechanism. After an emergency release, the chain stopper system should be inspected for signs of damage and deterioration. Any identified damage or deterioration should be rectified before the chain stopper is put back into service. Anchor handling winches should be provided with a permanently affixed nameplate which should include at least the following information: details of the manufacturer, name, address, model name, number, serial number, date of manufacture, date of installation, details of any power supply, details of the wire, example length, diameter, maximum brake holding capacity metric tons, maximum line pull metric tons, maximum static bollard pull metric tons, placeholder for the classification surveyor's stamp, and drum size and winch speed. Anchor handling winches should be certified by the administration or classification society which is recognised by the administration as compliant with SOLAS regulations 21.13.3.2, with a recommendation scope for demonstration of compliance of the anchor handling winches comprising of the following. This is before they're put into service for the first time: a plan appraisal for the anchor handling winch and foundation connections, verification of materials, survey, testing, examination during fabrication, verification of component certificates including loose gear, and testing and thorough examination when installed on board. Existing anchor handling winches with valid certificates under another international instrument acceptable to the administration and issued prior to the entry into force of SOLAS Regulation 21.13.3 should be considered compliant with SOLAS Regulation 2.13.2.5. A commissioning test should be carried out according with the manufacturer's instructions and the requirements of a classification society which is recognised by the administration in accordance with SOLAS Regulation 11.1.1 or with applicable national or international standards acceptable to the administration and which provide equivalent levels of safety. The commissioning test should include the following: function tests at light load to verify the correct working of the winch and its controls over the full operating range. An overload test to verify the capacity and integrity of the anchor handling winch, the attachment of the winch to the ship, and the adequacy of the ship's supporting structure. Test of the emergency release and residual holding force in the wire. The test should be performed with the wire attached to an onshore strong point or an anchor on the seabed or similar arrangement. Residual brake holding force after emergency release should be verified by the test. Function test of the whole winch system including static bollard pull test and brake holding capacity test. After repairs, modifications or alterations of the major character, which are those which change the rated wire pull of the anchor handling winch, affect the strength, stability or service life of the anchor handling winch, affect the primary load bearing structure of the anchor handling winch, or modify the functionality of the anchor handling winch or any part thereof which may affect its strength or safety or structural integrity, then the anchor handling winches are to be tested as the same for the commissioning tests. Function testing, overload testing, and a function testing of the whole winch system including the static bollard pull and brake holding capacity test. Anchor handling winches that are not designed for towing do not need to undergo the bollard pull test. Functional testing other than the static bollard pull test is still required. Anchor handling winches and associated equipment should be operationally tested annually and 5 yearly according to the manufacturer's recommendations and the requirements or recommendations of a classification society which is recognised by the administration. The annual test should include function tests of all the equipment. The administration or the RO should witness the 5 yearly test. Anchor handling winches and associated equipment are subject to thorough examination to the satisfaction of the administration during annual, before entering into service, and after any structural repairs or modifications of a major character and after any load testing. On completion of a thorough examination, the competent person considers the anchor handling winch to be unsafe for operation or not in compliance with the applicable requirements of the administration, then this should be dealt with in the same way as we described in the testing and examination of lifting gear. Records of the thorough examination and testing may be documented in any convenient form, provided each entry includes the necessary information and is clearly legible and authenticated by the competent person. Maintenance, inspection, operational testing and their respective intervals should be in accordance with the manufacturer's recommendations, industry standards and guidelines, or classification society requirements and recommendations acceptable to the administration. Examples of items requiring particular attention may include corrosion and damage of primary structural members, such as winch frames, bed plates, drums, foundations, foundation connections, including welds and bolts. Wear corrosion and damage of mechanical components, including hydraulic and pneumatic cylinders, pins, winch drums, chain wheels, wire spooling and guide systems, clutches, bearings, rollers, shafts, gears, bearings and brakes, correct setting and functioning of the safety and protection limiting devices, the condition and correct function of the anchor handling winch as a whole, in particular piping, hoses, hydraulic arrangements, spooling devices, motors, and electrical and control systems. Corrosion and damage to all means of safe access to the anchor handling winch, including the attached maintenance platforms and extensions, with particular attention to any support brackets and welds. Certification and identification of all wires. Damaged, broken, worn or corroded wires, including their terminations. Connecting the loose gears should be inspected and discarded according to the manufacturer's recommendations and any relevant industry standards, international standards or the requirements of the classification societies acceptable to the administration. All personnel involved in an anchor handling winch operation should understand their role during this operation. The procedures and instructions should relate to the specific type of anchor handling winch and should be provided in the operations manual and should take into account applicable international and national instruments and best practices for occupational health and safety. An operations and maintenance manual for the anchor handling winch should be provided by the manufacturer. Where operations and/or maintenance manuals for any existing anchor handling winches are not available from the manufacturer, these may be provided by competent third parties. The operations manual should, as a minimum, include the following for each anchor handling winch: the design, operational, environmental limitations, compatible loose gear, if any, safety instructions, and operating procedures, including emergency procedures, if any. For anchor handling winches installed before January 1, 2026, their operations manual should be developed with the original manufacturer, design and build data, and include any modifications since installation. Where the original data or modification data is not available, the operations manual should be developed on the current operational procedures and practices. The maintenance manual should, as a minimum, include the following for each anchor handling winch on the vessel: a description of the required inspection regime and maintenance schedules specific to the anchor handling winch, checklists and a list of key tools or other items for use when carrying out these inspections and maintenance, instructions for routine repairs and maintenance, technical maintenance information, information on recommended lubricants, oil and filter changes, information on bearing maintenance if it's applicable, lists of replaceable parts and components as well as inspection, maintenance, replacement procedures for these parts and components, lists of sources of spare parts, model forms for records of the inspections and maintenance that's carried out, operational test procedures as well as the pre and post operational test inspection procedures. A list of components requiring particular attention during inspections, as well as the inspection maintenance procedures for these components. Recommended intervals for replacement and overhaul of components and equipment. Information on the preservation of coating and corrosion protection systems. And information regarding special inspection and maintenance in cases where the anchor handling winch is not operated for a long period of time. Detailed specifications of anchor handling winches, such as the following information, can be included in other documentation, for example the anchor handling winch's operation maintenance manual on board. The date of manufacture and the date of installation, details of the power supply, details of any wires, lengths, diameters, maximum brake holding capacity in metric tons, maximum line pull in metric tons, maximum static bollard pull in metric tons, a placeholder for the Classification Society's surveyor's stamp, drum size and winch speed. It should be ensured that the documentation on board can be clearly related to the actual winch, i.e. by referring to the unique serial number. All records of the routine inspection and maintenance of anchor handling winches or their components or parts should be maintained and kept on board the vessel. These records and particulars of any inspection and all maintenance may be documented in any convenient form, provided each entry contains the necessary information, is clearly legible, and is authenticated by the responsible person. Any recommendations of the manufacturer for such inspection and maintenance records should be used. Loose gear. The guidelines for loose gear of anchor handling winches are broadly the same as with lifting appliances, so we'll only cover the slight difference as follows. Loose gear utilised with anchor handling winches, to which SOLAS Regulation 213.13.2.2 and 13.2.5 applies, should be designed and manufactured in accordance with the requirements acceptable to the administration or a classification society which is recognised by the administration. All loose gear should be clearly and permanently marked with its unique identification, i.e. serial number, the safe working load and any additional marks required for safe use. If there's insufficient space for the marking on the loose gear other than the safe working load, the omitted information should be included in the certificate or be provided by other suitable means. Dealing with inoperative anchor handling winches follows the same course of actions as inoperative lifting gear, as we've already covered previously. So different types of gear. We have deck cranes that are normally found on self-discharging bulk carriers and general cargo ships. Heavy lift slewing cranes are normally found on vessels that are required to conduct very heavy lift operations, such as offshore construction and wind farm installation vessels. Stiff boom cranes, commonly used for cargo hoses, any provisions and stores handling operations. Overhead gantry canes are commonly used in the engine room and normally sited over the main engine for heavy lifting of its components and spare parts. Derrick systems are less commonly found on board vessels, but historically were found on cargo and passenger ships for moving stores and cargo operations. So, common deficiencies. Common deficiencies in lifting appliances, cranes, derricks, davits. Failures in the main lifting appliances can be categorized into structural, mechanical and system related issues. Structural and mechanical failures. The marine environment is a primary contributor to the degradation of lifting appliances. Corrosion and wastage, excessive corrosion, rust, wastage on the crane structures, foundations, jibs and hollow members, which can trap water, are frequently reported. This is often accelerated by a lack of maintenance and protective coatings. Cracks and deformations, stress from heavy or fluctuating loads can lead to cracks, fractures and deformation in crane booms, pedestals and other structural components. Unauthorized or improper repairs such as welding inserts over damaged sections are a significant concern. Slewing bearing and bolt wear. The slewing ring and assembly is a critical component where excessive wear and slack bolts and damaged bearings are common findings. Failure to conduct regular checks such as rocking tests can lead to catastrophic failure in crane turrets. Brake and clutch malfunctions. Worn or improperly maintained brakes and clutches are a major safety risk, potentially leading to the loss of control over a load. Wire rope damage. These ropes are one of the most frequently cited items for deficiencies due to their exposure to constant stress and the elements. Common defects. Inspectors regularly find broken or frayed wires, significant corrosion, lack of lubrication, physical damage such as kinks, crushing, bird caging, basket deformation and abrasion. A discard criteria. A wire rope is typically rejected if its diameter is reduced by more than 8 to 10% from the original. If it has more than 10% of its wires broken in the length equal to 8 times its diameter. Control and safety system failures, hydraulic system issues, leaking of hydraulic lines, contaminated hydraulic oil, often with water or dirt. Blocked coolers are common problems, and this can cause the slow, erratic or complete failure of the crane functions. Electrical faults, defective wiring, faulty limit switches, inoperative control systems are frequently noted deficiencies. Bypass safety devices. A critical and dangerous finding is safety devices such as load limiters, hoisting or slewing limits. They're either not functioning correctly or being deliberately bypassed. Documentation procedural lapses, missing records. P&I clubs and surveyors often report a lack of proper documentation, including missing or incomplete registers of lifting appliances, test certificates and maintenance records. Lack of training. Accidents are frequently attributed to human error, including a lack of operator familiarity with the equipment, improper operation, and overloading of the appliance beyond its safe working load. Common deficiencies in loose gear, slings, shackles, hooks. Loose gear is often poorly managed, leading to a high rate of deficiencies. Missing and illegible markings. The single most reason for rejecting loose gear is missing, illegible or distorted identification tags. Every item must be clear marked with its safe working load and unique identification number. In this absence, the information makes it impossible to verify the item's capacity, certification, requiring its immediate removal from service. Physical damage and wear. Synthetic slings, web and round slings. These are highly susceptible to cuts, tears, punctures, abrasion, especially if used on loads with sharp edges without any proper protection. Other common defects include broken stitching, chemical burns and degradation from UV sunlight exposure. Chain slings. Inspectors often find stretched or bent links, excessive wear, nicks, gouges and heat damage, which can be indicated by discoloration or, say, weld spatter. Hooks. Common issues include deformation, such as an increased throat opening, cracks, excessive wear to the saddle, and missing or inoperative safety latches. Shackles. Besides general wear and corrosion, specific deficiencies include bent pins, damaged or worn threads, and wear on the body or pin exceeding 10% of the original dimensions. Shackle pins for gangway fittings are often found unsecured or unmoused. Ultimately, the prevention of these common deficiencies relies on a robust safety culture that prioritizes regular inspection, diligent maintenance by trained crew, and meticulous record keeping. From damages entered into our reporting tool from the previous 5 years, the chart shows the damage types that have been recorded by us as the surveyors. It has been noted that cracks, fractures and deformation account for a high percentage of the deficiencies that we find during our inspections. And the detail of the damages is shown. It can be seen that approximately 35% are noted on the jib. So we have our BV rules and procedures briefly outlined here. We have rule note 467, rules for the classification of steel ships. Rule Note 526 for the classification of lifting appliances on board ships and offshore units. Rule Note 266, the requirements for survey of materials and equipment for the classification of ships and offshore units. Rule Note 216, and that's the rules on materials and welding for the classification of marine units. Rule Note 595, classification of offshore handling systems. And our quality documentation, obviously always HSE 0002, Section 4, TNS 0002, Section 5, TNS 0003, Section 12, and TNS 0015, cargo gear, where these might have some updates coming shortly. The Register of Ships Lifting Appliances and Cargo Handling Gear is a well-known document to you all. This is presently being updated and should be available digitally in due course. During each intervention, the required documents are to be completed and issued to the vessel. These documents should be filed with the Register of Ships Lifting Appliances and Cargo Handling Gear. These should be issued utilising our digital certificate platform, where they will be emailed to the client directly to be filed in the ship's file and available in the Fleet in Service application for the vessel. Surveys are required for two primary reasons. To maintain the class of the ship, the fixed parts of the lifting appliances must be submitted to survey requirements. To validate the Register of Ships Lifting Appliances and/or to maintain any additional class notations, the lifting appliances and their accessories must be submitted to specific thorough examinations. A thorough examination is defined as a detailed visual examination attended by a society surveyor. It may be supplemented by non-destructive tests or dismantling of the components if the surveyor deems it necessary. There are two main types of examinations required to maintain the ship's register of lifting appliances and cargo handling gear and the class notations, and therefore maintain the vessel's class. Annually, there is a thorough examination, a detailed examination and test conducted annually. At a maximum of 5 years, there's a quinquennial thorough examination that includes all elements of the annual thorough examination, plus the systemic checks and compulsory retesting of the lifting appliances. The annual examination involves the following key points that have been summarised. A documentation review must be conducted upon commencing the survey. The surveyor must be shown the Register of Ships Lifting Appliances and Cargo Handling Gear and any attached documents to ensure they are up to date and no alterations have been made. If there has been any, this must have been declared by the master to the attending surveyor. We must ensure that we have safe access to all the required parts of the lifting appliances. The ship's responsible person must provide the surveyor with safe conditions to conduct the examinations. This includes lowering derrick booms and crane jibs where possible and ensuring ladders and gangways are in satisfactory condition. Ensure that any safety harness has been inspected and is still valid, and then ensure it is worn for any and all working at height activities. Wherever required, dismantling and preparation of the lifting appliance should have been communicated with the vessel prior to attendance to ensure it is as required for the survey of these required items. The surveyor may require additional elements be dismantled by skilled personnel, cleaned and have protective coatings, for example paint, removed for any crack or corrosion detection if there's any areas of concern that's noted during their inspection. The surveyor conducts a detailed visual inspection of numerous components, including fixed parts, check for corrosion, deformation and damage, with special attention paid to hull connections, adjacent structures examined above and under the deck, including crane mounting rings and rails, removable structures, joints, pivots, goosenecks and pins are examined for cracks, deformation and ensuring proper greasing. Crane jibs checked for distortion, buckling, corrosion or impacts. Crane slewing rings examined for cracks and abnormal clearances. Loose gear inspected for distortion, cracks, wear or corrosion. Blocks checked to ensure the sheaves rotate freely and grooves are not excessively worn. Ropes, wire and fibre ropes are inspected for corrosion, wear, broken wires, deformations and the condition of the terminations. Winches examined for general maintenance, lubrication, the foundations, locking devices and brake lining wear. The surveyor must conduct operational checks and confirm the good operation of the machinery, control devices and brakes by carrying out no-load manoeuvres. Safety devices, example limit switches, load indicators, emergency stops, are to be checked to ensure they are fitted and fully operational. The quinquennial examination includes all the procedures from the annual thorough examination and is supplemented further by further inspections and tests as follows. The surveyor systematically checks compliance with the rigging drawings, ensures all the rigging list is up to date and verifies the test certificates for the loose gear are on board. The surveyor determines the number of thickness measurements to be taken. From the third quinquennial examination onwards, thickness measurements are to be made systematically. Systematic dismantling of the equipment includes, as a rule, all hinge connections like the jib heel pins, blocks, their pins, several fixing bolts for crane slewing rings are to be stripped down. Non-destructive tests of the crane mounting and slewing rings are to be especially examined for cracks. All lifting appliances must be retested upon each quinquennial examination. This must include at a minimum an overload test under the specified proof load, a manoeuvring test which may be carried out with no load or under a load lower than the safe working load for the lifting appliance. Occasional interventions are required further to any damages, repairs or conversions to the lifting appliances. If a lifting appliance or its support structure is damaged, the owner must apply to the Society for a survey as soon as possible. The proposed repairs must be made in agreement with and under the survey of a Society surveyor. The final decision regarding the repair or replacement rests with the surveyor. If a load carrying element is repaired or replaced, the lifting appliance must be retested, including an overload test. Any project to modify the characteristics, for example the strength, operation or safe working limit of a lifting appliance, it must be submitted to the Society for approval before the work starts. After conversion, the appliance must be retested. The owner and/or operator has the responsibility to ensure the responsible person or designated staff on board conducts regular inspections and normal maintenance as required. This is also covered in our Rule Note 467 Part A, Chapter 1, Section 1, Operation and Maintenance of Ships, where it is stated it's in the interested party's responsibility to ensure proper maintenance of the ship until the next survey. Any noticeable incident or accident involving lifting appliances must be notified to the Society. Any project for repair or alteration affecting the strength must be submitted for agreement. The owner-operators are responsible for checking that the survey requirements and periodicities are admissible by relevant national authorities, example flag state or port authorities, which may have more severe regulations. The maximum allowable wear by friction or corrosion is estimated by the surveyor depending on the element concerned and its working conditions and the possible effects of its failure on the reliability of the lifting appliance. The maximum wear limits are given for guidance, however, repair or replacement of the element concerned may be required by the surveyor before the limits are reached. Plate thickness of load carrying members, a 10% reduction in the thickness at any point. 20% reduction for any localized wear or corrosion which concerns only a small portion of a cross-section of the structure. In sections, a 10% reduction in cross-sectional area of any primary element in the case of wear or corrosion that's evenly distributed across the considered cross-section. 20% reduction locally when the section concerned is a secondary element only. Elements of circular cross-sectional area, 3% reduction in diameter at any point on the same cross-section with 1 millimeter at least, and 5% locally in any particular direction with 1 millimeter at least. When the plates, sections and elements of circular cross-section have reached the maximum wear limit mentioned above, they are to be replaced. In agreement with the surveyor, very localized corroded areas may be built up by welding. Pins which have reached their wear limit are to be replaced. It is necessary to check that the apparent wear of the pin is not actually a deformation due to shear, which requires an immediate replacement, whatever the magnitude of the deformation noticed. Thank you for your attention.